so in 27 here we have a square system. Square meaning we have the same number of variables as equations, and it's three equations, three variables. It's linear, so we're going to try elimination. So we could eliminate x, we could eliminate y, or we could eliminate z. It doesn't matter. Y and z look like the easiest because you have that negative y or that negative z. So it really doesn't matter. Like if we add equations 1 and 3, y will eliminate or z will eliminate actually. So that's interesting. So let's just add equations 1 and 3 together because to eliminate our y's. But then our z's are going to eliminate too. Alright, so when we add equations 1 and 3 together, we get 5x, and then y plus negative y. That cancels out. Let me do it like this. Alright, so that plus that is 5x. That plus that just cancels out. That plus that just cancels out. And then 7 plus 5 is 12. So we have x is equal to 12 fifths. Alright, so we got x now. Now we have to eliminate. Let's try to do that again, but with two other variables. Alright, so when you add equations 1 and 3 together and solve, you get x is equal to 12 fifths. Sorry, not 5/12. Alright, so now let's add like equations 1 and 2 together to try to eliminate z. So we're going to have to double equation 1 because there's a negative z. Alright, so now if I do 2 times equation 1 plus equation 2, alright, so 2 times equation 1 would give me like a 4x plus x would give me 5x. Having trouble writing this because technical difficulties. Come on, write. It's not writing on my screen. Sorry about that. Alright, over here I'll write. That's weird. Alright, so 2 times equation 1 plus equation 2 gives us 5x, and then we get a 2y, and then those cancel out. So we get 0y, and then sorry, it's not writing. And then negative 2z plus 2z also cancels out. And then we get 2 times 7 is 14. 14 plus negative 9 is 5. Alright, and then we get that x is equal to 1. Alright, so this is called an inconsistent system. It's giving us two answers that are different from each other. Alright, so that means there's no solution to this. It's impossible for x to equal 12 fifths and x equals 1. And that's going to happen when you go to eliminate one variable and then the other variable also eliminates. So you could solve for that one variable like we did. So we eliminated y and z and we solved for x. And then we did that with another two pairs of equation. The same thing happened, but we got a different value for x. Alright, so that's how we know there's no solution. And graphically, these would be three planes that are parallel, so they never intersect. So there's no point that works in all three equations.